One of the main inspirations for VOIDSWARM is a TV show and book series called The Expanse. If you've watched it, it needs no introduction, you know how great it is, but one of the things that makes it great is that it's hard sci-fi. So all of the ships move under physics. When they're trying to reach a destination, they burn halfway there, get up to their top speed, and then they flip and burn in the opposite direction so that by the time they reach their destination, they have 0 speed left. It is a great detail in that story because it means moving around the world has a weightiness to it. It takes time to reach places. It affects the decisions that the characters make. We're trying to build that weightiness into VOIDSWARM. It's a strategy game. The decision to move units across huge distances should really matter. It should take time. And having this weighty movement system really sells the scale of the game as well. It makes you feel like you're playing in an entire solar system rather than just a little sandbox. Some other space games already use similar systems, but they tend to not be strategy games. Those strategy games tend to use less physics-based systems and have units that, might have a top speed, they might accelerate and decelerate quite quickly, they might be able to turn on a dime. That's not what we're going for. You end up seeing a lot of other space games that have more arcadey movement, and that works great for those games. It's baked into the design of the gameplay for those titles, and it works well for them, but it's not what we're after here. It affects every choice the player makes in VOIDSWARM. When they're picking their personal ship, they might pick a heavy ship that struggles to get out of harm's way but can really lock down an area. They might choose a light ship that can more easily dodge between enemies. It makes the choice for strategy more meaningful because large destroyer ships take ages to reach their targets, but they're devastating when they get there. Do you, as the fleet commander, have time to send one of those ships in an emergency? Should you dispatch fast movers? Those types of decisions then knock back onto your build decisions for how you build your fleet out, and that affects your build economy. So these things all have knock-on effects. Since this is a core design decision in VOIDSWARM, we spent several weeks building the core systems, and we continue to iterate on them to improve them during development. If this sounds interesting to you in any way, if the development of VOIDSWARM sounds interesting, please subscribe to the channel. We're going to post more of these devlogs in the future on a regular cadence, hopefully. Or if the game itself sounds interesting, please do drop us a wish list for it on Steam. The links are below. So let's talk about how this new movement system is designed. Most off-the-shelf pathfinding solutions give a predetermined path for a unit to follow, and they assume that every unit can be fairly reactive in the way that they move. They might be able to turn on a dime, they accelerate and decelerate quickly, they have a top speed, everything like that. Those assumptions don't work in VOIDSWARM in this hard sci-fi system, and because of that we need to design a new system that can account for this physics-based movement. So instead of setting a predetermined path for our units to take, what we actually want to do is give them a goal. Let's say a ship is given an order to fly to another planet. This goals-based system takes the planet position and orbital, info about the ship like its current position, distance from the planet, current velocity, its mass, its thrust, and it calculates a position to fly to. This takes time for the ship to do, and the planets are in orbit around the sun, so our system needs to calculate where the planet will be by the time it predicts the ship will arrive. This target position is then used as the goal for our navigation system. It doesn't tell the ship how to reach the target, it just tells them where they're heading to. Our navigation system takes that as an input, and then it feeds in other data about the direction the ship is currently moving, how fast it's moving, how agile it is, and which direction the target location is in. And it uses that info to try and point the ship towards the target location and move in that direction. During this, it cares mainly about a few different things. It cares about whether it can slow down in time to not overshoot the destination, and this is that flip and burn behavior that I was talking about before. It cares about whether it's being acted upon by external forces like gravity and tries to factor in how to account for that external force. And then it looks for obstacles in the way of the direction that it's travelling. It looks ahead a few seconds to look out for those hazards. Hazard avoidance is really one of the big features of this system, so let's zoom in on that for a second. Let's say a ship is travelling at 100 units per second, and we want to look in front of the ship by 5 seconds. So we know we can shoot a ray out of the front of the ship that's 500 units long. If that ray hits an obstacle, we know that there's an obstacle to move around coming up. So how do we move around the obstacle? Well, we already have one direction baked into our system. That's the direction to the target location. When our ray hits an obstacle, it gives us another direction to think about. It gets something called the normal of that hit, which is effectively the direction pointing away from the obstacle. So now we have these two directions. We've got the one that goes towards the target location, and we've got one that points away from the obstacle. And by blending between the two of these, we can effectively move towards our target whilst moving away from the obstacle. And lo and behold, we've now got ships that move around planets instead of crashing through them. This is the basis of how all ships move in VOIDSWARM. They don't have a predicted path or trajectory, they simply move towards a target and react to anything that might throw them off that course. And this lets us have full physics-based movement. We don't hit the pitfall of traditional pathfinding systems that are better suited to non-physics-based movement. It means every ship is responsible for its own movement. We get really high fidelity across thousands of ships, and we get a lot of flexibility in two main ways. As the game developer and designer, I can change how the target location is decided and calculated depending on what task the ship has. For example, I can calculate the target location differently depending on if the ship is escorting another ship, gathering XP drops, scouting an enemy position for intel, defending or attacking a base, or mining a resource node. And the second flexibility it gives us is that it means it's inherently reactive to changes in the world. I can add new obstacles super easily. The ship doesn't need to know anything about what the obstacle is. They don't need to predict where any obstacles will be at any arbitrary point in the future, which they would need to do if they were using one of these more deterministic systems. And that would get really expensive really quickly to calculate for thousands of ships. Speaking about how expensive things are, just worth touching on performance quickly. For thousands of ships, even this system that I've designed, if we ran it every frame over every ship, the performance would really suffer. So what we do instead is we use something called time slicing. So each ship only actually updates its calculation of the target position and its heading 8 times per second, with a very small amount of randomization in the time between these ticks to ensure that only a tiny proportion of the ships in total are updating at the same time. This means that instead of having 1,000 ships updating every frame, we might only have 100, and that immediately saves us 90% of the performance cost. I'm not going to go into the technical detail, but we also use something called data-oriented tech stack, and what that really lets us do in VOIDSWARM is move from the default system in Unity, which is really single-threaded, it effectively in layman's terms only runs on one core of the CPU, to a fully multi-threaded system that, you know, in the case of something like a PS5, which has 16 threads per processor, you can split that workload across 16 workers. So instead of having 1,000 ships in that original example being updated every frame, you know, with time slicing it might only be 100, and with multi-threading, each thread might only be working on 6 ships at a time. And that means that the overall cost to calculate the movement for all of these ships is reduced by 99.4% overall. But there are some limitations with that system. No system is perfect. Those off-the-shelf solutions still get used a lot today in really popular games for a good reason, even though it's not a perfect fit for our game. The limitations of our movement system are largely to do with it being built around reactivity rather than proactivity. One of the ways that manifests is if there is an obstacle in front of a ship, it gets a new heading to try and turn away from it. But what if that heading is then pointed towards another obstacle? You know, what if you point away from our planet and towards a moon? We do one extra check on that new heading to see if we're putting the ship onto a new collision course. And if we are, we try to thread the ship between those two obstacles. Now, strictly speaking, you might need to do that a 3rd time, or a 4th time, or a 5th time. That gets really expensive, so we avoid doing that and only do one look-ahead check. If there are lots of obstacles in an area, a ship doesn't know about all of them at the same time. That works fine for VOIDSWARM. It's not a scenario that ships ever really find themselves in by design, but it is a technical limitation. The other is that because we don't have a predetermined path that factors in the movement of every obstacle in the solar system at the same time into its calculation, it means the ships don't necessarily know if an obstacle is going to enter their path ahead of time. What that fundamentally means is that we can't always accurately predict how long a journey is going to take for a ship. We can estimate it, but it's not perfect. Having said that, we think these are really worthwhile trade-offs to make to have a system that is fully physics-based and that scales across thousands of ships even on modest hardware like handhelds. So that's really how the movement system for VOIDSWARM works. We want to make the physics-based movement core to the game design for the title. We want to make ships feel more grounded. We want to make the decision to move units as the fleet commander feel more meaningful. We want that to impact how the player builds their fleet, how they think about the economy that they're having to operate in. And it also has this added side effect of being really intuitive for new players. You know, you point a ship in a direction, you thrust in that direction, and you move in that direction. No arbitrary limits to do with top speed. And it also has a higher skill ceiling for skilled players who need to manage momentum, they need to manage the time it takes for their units to move around. So that's it. If that was interesting to you, please consider subscribing to the channel. We'll do more of these devlogs in the near future as we develop the game further, and if the game sounds like something that you'd be interested in playing, the Steam page is already published on Steam, so please wishlist the game. Until next time, see you later.